Before going further, let's look at the different data models. The ER diagram, which is for OLTP system, and this is how the data model is, which is represented by ER diagram or entity relationship diagram. So we have defined 5 different entities: customers, orders, order items, products, and sellers. And then we define the relationship between them, between customers, order items, products, and orders and sellers. And then let's look at the data model of our data warehouse, which use the same data that I'm showing you here. Now this is the data model of the data warehouse using the same data and same tables like customer, product, orders, etc. But here what we have done is that we have created a fact table with orders underscore fact and multiple dimensions table like customer underscore dim, payment dim, which is very new. It was not there in OLTP system. Date dim, which was also not there in OLTP system. Seller dim and product dim. Here what I have done is I have combined orders table and order items table to create orders underscore fact. But I have taken only the price and discount value. And I have pushed the date to date dimension. I have pushed the payment method to payment underscore dim table. Also, the product description has been pushed to product underscore dim table. So as you can see, the structure has changed completely even though the data is same. And that is how it is. Even for the simplistic systems or simplistic workloads, the data model for OLTP and OLAP can be substantially different. So that's why we need to transform the data as we move them from OLTP to data warehousing system. So this is our OLTP source, and then we have OLAP target or data warehousing target, and then we have transformation. What this transformation process does, it pulls the data from the source systems and then does the transformation as per the fact tables which are there in DWH, or does the transformation as per the dimension table. Dimension tables are loaded less frequently than fact tables, and then loads the data. So data from sources are moved to target after transformation, and we call this transformation process as ETL or ELT. ETL means extract, transform, load, and ELT means extract, load, and transform. The diagram that you see here, it is a typical ETL process. So extract the data from source, we do the transformation, and then load the data. So if you use ELT, the transformation would happen, or this box would go after the DWH target. What we would do would load the data directly from source to target, and then we'll do transformation either using various platforms or using SQL, and then load it back again. So the tools that are used for transformation are Spark, AWS Glue, AWS EMR, Google Cloud's Dataproc, Redshift, Snowflake, BigQuery, etc. Now, if we use Redshift, then let's say we fetch the data from source, move it to Redshift directly without any transformation, and then we can use Spark or Redshift SQL to do the transformation and load it back again. So there's a feature of Redshift called Zero ETL that exactly does the same. So we move the record from source system to the target data warehouse system directly, and then we do the transformation. We have similar thing for Snowflake and BigQuery also. We can also do transformation from streaming sources using platforms like Spark Streaming, Flink, Redshift Streaming Ingestion, BigQuery's Ingestion, Snowpipe provided by Snowflake. So all these load data from streaming sources and then do the transformation and load it back again. Spark Streaming and Flink are ETL, but the others are ELT. So that's why transformation is very, very important, because as you have seen, the data model changes drastically between source and target, or between OLTP and OLAP. Without transformation, it would be very difficult to plant the data as needed by the by the data warehousing systems. There are a few other concepts that I want to talk about, like data virtualization. Now, this also falls under the umbrella of data modeling. So I'll give you a high level overview of data virtualization. So let's say I have multiple different data sources like SQL databases or relational databases. Then you have NoSQL databases like DynamoDB, Bigtable, MongoDB, etc. Then you have databases like Redshift, BigQuery, which are data warehousing systems. We can also have data APIs, which provide APIs to fetch data or download data that can also be used. We can also store in data lakes and lake houses. So if that is the case, if you have so many data sources which are very different from each other, how do we use these different data sources together for business analysis? Of course, we can move all of them to data warehouse, but let's say the use case is as such that we do not need to load all of them. We need them on an ad hoc basis. And for those ad hoc basis, some business analysis would be done from the data which are stored in these different data sources. So you might have guessed that we can use data virtualization technique. It is a virtualization layer on top of these different data stores. And what we do here is we create different views. And I hope you already know what views are. So these different views are created from pulling data from various different sources. So view 1 can contain data from, let's say, 10 NoSQL tables and maybe 5 SQL tables. View 2 might contain 1 NoSQL table, 2 OLTP tables, and maybe 3 data warehouse tables. Same is the case with view 3 and view 4 also. So this is what a data virtualization layer is. And we have various tools and technologies like Denodo, Athena, Presto, Trino, which can be used as data virtualization technique. Now, if you don't know what Athena, Presto, and Trino is, the underlining of these tools are SQL Anywhere. So you can run SQL on any one of these data sources. So we can use this to create data virtualization layer. There's a separate platform called Denodo also, which is meant specifically for data virtualization creation. And then we can do business analysis on top of it using tools like Power BI, MicroStrategy, Tableau, QuickSight, etc., which would sit on top of the data virtualization layer. So this is one of the technique that is used a lot. Then there's one more technique, or there are a few other components like semantic and presentation layers. So what are these? These are again logical constructs, just like data virtualization. So the underlining of these layers is that data in data warehouse is considered to be raw data. Now, raw data from the perspective of end users or business users like CXOs, business development managers, business analysts, data analysts, etc. Because if you see in data warehouse, the column names are like customer underscore ID, effective EFF underscore date, or DEL underscore DT, things like that. So those column names might not make any sense to the business users. Even if we have data warehouse, those data are actually raw vis-a-vis the business end users. So that's where semantic layer is used to translate the raw data into business friendly names and business friendly data also by joining multiple tables, renaming columns, etc. Now the purpose of semantic layer is to make sure that the end users understand the data and the columns. So it sits on top of the data warehouse layer, which translates the raw data into business friendly names and business friendly data for end users. And there are various tools like Power BI, Tableau, Dremio, Qlik, etc., which can be used to create semantic layer. Then we have presentation layer, which is basically the interface that is used by end users to get business sense out of the data which is there in data warehouse. So the reports are actually generated in the presentation layer. And the tools for presentation layer are similar to semantic layer like Power BI, Tableau, Dremio, MicroStrategy, Qlik, etc. So that's all about data modeling. And before concluding, I want to summarize. So I started with data modeling introduction and terminologies, wherein I talked about entity, which is nothing but table, then attributes, which are nothing but columns in a table, and then relation, like how two tables are related to each other with data. Then I talked about primary key, which is used to uniquely identify a row in a table. And foreign key is used to create the relationship between two tables. Then I talked about various modeling concepts like normalization. And there are various normalization forms, but I talked about only three: first normal, second normal, and third normal form. Then I talked about relationships, which is again based on data: one to one to many to one, and many to many. Now, how do you define the relationship? I had also shown you the diagram that is used to define the relationship, and the best way to do it is define it from the perspective of one entity. Once that is done, go to the other entity and always try to define it based on one record. So let's say orders and customers. If you go to orders, for each order, how many customer can be there? There can be only one customer. And for each customer, how many order can be there? There can be many orders. So customer and order follow one to many relationship. Then I also talked about denormalization, which is basically keeping a table in first normal form. And the reason of normalization was to reduce redundancy or remove duplicates, because storage used to be costly. But we need to run SQL joins, which are CPU intensive. Now, if you fast forward to today, storage is much cheaper. So that's why denormalization makes more sense. Now, it's not that you will always denormalize, it will depend on your use case. So after talking about these, I mentioned about data modeling techniques like ER diagram or entity relationship diagram and dimensional modeling. Entity relationship diagram is used for OLTP relational databases, and dimensional modeling is used for OLAP relational databases. Then I talked about multiple concepts called fact tables, dimension tables, star schema, and snowflake schema, followed by a very important concept called grains, which is used to define the granularity for a fact table. Then I discussed various types of facts and dimension tables like additive fact, semi-additive fact, non-additive fact, periodic snapshot fact, accumulative snapshot fact, SCD 0, 1, 2, 3. Then I talked about two logical constructs which are considered to be part of data modeling. One is data virtualization and then semantic and presentation layer. So that's all about data modeling. I hope it was helpful. Thank you and see you in the next video.